Okay, 5-3 graphing radical functions. So when I started this year, well, actually we started last year a little bit, I told you every single time I introduced a graph, we'd have an H and a K. And H was horizontal movement, and K is vertical. And it's happened every single time, correct?
Yeah.
Okay, and it will continue to happen even with radicals. We are going to graph square root functions, okay, but other roots would be exactly the same, just a different initial shape, okay? So the parent function of a square root, well, let's talk about it. So we're going y equals the square root of x. Okay, and we'll add more to it in a minute. So what happens if I plug in negative 10 to this? Can I take the square root of negative 10?
No.
You have to put an I.
Yeah, I'd have to have imaginary, right? And I can't graph that. What's the first number I can take the square root of?
You had what?
4. And 2. No.
1.
1, 6, 7, 8, 9,
It's
10.
9. Isn't it 1?
I can't take a square root of a half.
Oh yeah, got it again.
What's the first non-negative number?
1/2. A 4.
What is on a number line? What is the first non-negative
0.
number? 0. What's the square root of 0?
0.
0.
I thought.
The square root of 0 is 0. Yes? I didn't say perfect square.
Okay.
We can take the square root. They're irrational numbers, but they're real. Yes?
Yeah.
Okay? So what's the next nice square root?
4.
1. Right?
Sure.
So 1 is what? What's the square root of 1?
1.
1. Then we have 4. What's the square root of 4?
2.
2. So is this going to go up fast? Is it going to shoot up fast?
No.
No. It's going to go slow. The square root function looks like that.
That's gross.
Okay? So if you think about it, what did x squared look like? What shape is x squared? It's a parabola, yes?
Yeah.
Okay? And a parabola that started at 0, 0, yes? And it went like this? And like this? Well, if you use your imagination, a square root looks like what of a parabola? Like half of it, yes? Only the positive numbers?
A sideways.
Right, but only the
Yeah.
positive numbers?
Yeah.
Okay. So, if I put them both on the same graph, what's 1 squared? 1. And what's 2 squared? 4. So if I put them both on the same graph, but only the positive numbers, look at them. Are they inverses of each other?
It's inverted.
Okay. So this is y equals x squared, but only the positive x's.
Sure.
So y equals x squared, where x is greater than equal to 0. Okay. And this, okay. So I constructed this without knowing anything about the shape of the graph, didn't I?
Mm-hmm.
But now you know. So we are going to move, when we had a parabola, we moved 0, 0, we moved it left, right, up, and down, yes? And then drew our shape, and we reflected it. So can we do the same thing here and still with 0, 0?
Mm-hmm.
Yes. Okay, we're still going to move that vertex. So that equation is going to be y equals plus or minus a, the square root of x minus h plus k.
What is this called?
Have we done this before?
Yep, we did it with y equals plus or minus a, x minus h squared plus k, didn't we?
Yeah.
Okay, But this is a parabola because it's what?
Square.
Squared. This is this shape because it's a
Square root.
square root. Is the same thing going to happen? This plus or minus is going to reflect it over the horizontal axis. If I put a negative on the x, it would reflect it over the vertical. H is going to move it
Or side to side.
side to side, horizontal. K is going to move it
Up and down.
vertical. And on the H, it's going to be the opposite direction because there's a what?
Negative.
Negative. Everything else is going to work the same. And we've actually done parabolas 3 times already this, and we're only on chapter 5. And there's a reason why we did parabolas 3 times. Because when we start introducing the rest, you need to apply the same things to a different shape. Okay? So if we had a cube root would look like this. Well, it would be this whole thing. Okay? A fourth root would look like this. A fifth root would look like this. What's the same about those?
They're
So
odd
the-
numbers.
Odd and even. Because odd, can I take an odd root of a negative number?
Okay.
Of a negative, so I would have another tail, wouldn't I? Can I take the even root of a negative number? No. So all even roots are going to go this way, and odd are going to go like this.
What's that one called? Does it have a name?
Which, this one?
Yeah.
This would be like a cube root. So, but all even roots are going to generally have the same shape. Now, when we did a parabola and this was square root, remember like the fourth root would be up here and the sixth root would be like here. They get closer and closer to the y-axis. So the larger and the larger of the root, guess where it gets closer to? The x-axis. It gets flatter and flatter and flatter because you have to go further out for every y. Like the cube root of 8 is 2, right?
Mm-hmm.
So where the square root of 4 was 2, the cube root of 8 would be 2. So it wouldn't be 2 till clear out here. Does that make sense? It wouldn't have so much of an arc. Okay, so left, right, up, down.
B-A.
Let's give you the odd root. This is an even, yes. We particularly said square, but would that go for a fourth root or sixth root? Yes. So this is an even root. Is that shape? So if I did y equals the cube root of x, we're still going to get y equals plus or minus a, the cube root of x minus h plus k. Going to look exactly the same there, right?
Mm-hmm.
But it's going to be my parent function. So we're going to start at 0, 0. Cube root of 0 is
0,
0. Cube root of 1 is 1. Cube root of negative 1 is negative 1.
Yep.
Okay. What's the next nice cube root?
3. 9.
27.
How about 8?
Oh, yeah.
8. Yeah.
8?
8. Oh, that's what I was thinking.
I need a longer. We are not going to go any further than 8. Because the next one is what? 27.
How will it have us in the assignment?
It's cube root of 2. Well, 2 times 2 times 2 is 8. 2 cubed.
Not, I don't know about today. Not today. Okay. So now, the cube root of 8 is what?
2.
2. So go up to 2. The cube root of negative 8 is negative 2. And so the shape is going to go nice smooth curve like this. So this would be the same shape for any what? Odd root. So the point we're moving though is what point?
0.
0, 0. So that 0, 0 would move. So what would happen if the A was negative to this? It would do what?
It would be flipped.
It would be flipped. It'd start positive and end negative. Okay? What happens if the X, it would go this way, yes?
Mm-hmm.
So if I reflected this over the X or the Y, wouldn't it look exactly the same?
Yeah.
It would. So when that happens, we tend not to ever do it over the Y. We only do it over the X. Now, up here, if I reflect this over the X, it's going to look different, yes?
Mhm.
What if I reflect it over the Y? Is it going to look different?
Yeah.
Yeah. What if I do the X and the Y?
No.
It's going to say something.
And no. X and Y would come over here.
Opposite.
So on a even root, is every reflection going to have a different look?
No.
It won't look the same across the
Yeah, across the X. This would be across the X.
Yeah.
Okay, this would be a negative A. Okay,
Yeah.
this would be a negative X.
Yeah.
And this would be a negative A and a negative X. Because we only have how many pieces? We have one piece.
Oh, okay.
And when we have one
I went
piece-
through.
Yeah, no.
Okay.
It would just be this piece. It would be here if it was a negative A, here if it was a negative X,
Okay.
here if it would be a negative X or A and A. Sorry. But this, since I have two pieces, it's going to look the same.
The metal.
Well, not no matter what,
Okay.
but yes. If I did a reflection over the y-axis, it would look the same as if I did it over the x-axis. Okay, so let's do some telling me what's happening. How about that? Or, yeah. So, g of x equals 2 the square root of x plus 3 plus 5. Oh, that's crooked.
Yes, sir, yes.
There we go. My camera was crooked.
I think it's operator.
Probably. Okay, so 0, 0, that vertex, where's it going to go?
2. No.
No.
5.
Negative 3, 5.
Oh, the X is first.
Yes, x is first. So the parent function went like this, yes? Logan?
What?
Parent function went like this, yes? So now it's going to go to negative 3 and 5. So it's going to start here. So this up here would be my new axis of the curve. Does that make sense?
-3.
Negative 3, 5. What is this 2 going to do to it?
That's
It's going to take every answer and multiply it by 2. So instead of getting closer to this axis, it would get
Farther.
farther away. So it, like this one goes here, this one would go there. Just a sketch.
We have to put that.
If it says sketch it, yes.
We don't actually have to do any work. It just says that.
Nope, because this said it here, and this is going to, probably we would say wider. Is this wider? When you, according to the x-axis, is this wider?
yeah.
Okay. And remember when A was, well, it's going to be different because it's a different direction. Never mind. It pulls it, it stretches those.
Wait, what's
That A is greater than 1. it's going to stretch the y.
What's the curved dotted line? That's the.
That was the parent function. And then this was the new axis because we took our axis from here to here,
Okay.
moved it up. Okay, so, and this one says graph. They do both say graph. G of x equals negative 1/2 the square root of x minus 1 minus 3. So we're going to identify the same thing we did here.
Would I get closer to?
So our parent function looks like this.
1 and -3.
Okay, so 0, 0. And I would advise you to say 0, 0 goes to, so you always remember. Would be not -1,
Positive.
+1, -3. What is that? Negative, tell me.
That's gonna tell you your new axis.
Reflects over axis. I'm just going to put, you can write x-axis, but we are going to move that x-axis where? To -3?
Yep.
Okay?
Yeah, I would.
Or you could put h, how about h-axis? Or you could write new axis.
Because it wouldn't be the old one.
It wouldn't be it wouldn't be the x-axis because we're moving it.
Okay.
Okay? Or you could reflect it over the x-axis and then move it.
Yeah.
So either way you want to look at it. What?
Do you always move it?
Not always, but this tells me I'm going down 3. So if I'm moving
So
vertically,
if it doesn't change,
if vertical doesn't change, it'd be x-axis. But you can always reflect first, then move down. So you can always write x-axis because we could reflect and then move. Okay, what else is going to happen? What's this going to do to it? Is it going to change it? So let's see what it's going to do in a second, okay? So the new axis is at where? -3?
-3, 1.
So our new axis is here. And we're moving the starting point to here. Yes? And it's reflecting here. But after I do everything, I'm going to take what of it? Half.
-1.
Well, I'm going to take half of whatever results here and then subtract 3, yes? So would that draw it closer to this axis or pull it further away?
Further away.
Closer.
And closer.
I don't know.
Okay? So my graph would go.
There's only 2 guesses.
Now, I don't know how much, and I'm not going to make a table. Okay? So we can say closer or narrower. Or you can say closer to new axis. Whichever one makes sense in your brain. Logan, do you need to stand up? No, you are not. Okay. So whatever makes sense in your brain. When I see narrower, I think narrower to the x-axis. But when we did parabola, when we did narrow, it was narrower to the y-axis because that's the direction it was. Okay? So does that make sense?
Yeah.
Okay. So I'm going to pause this and we're going to get our...
That?
Okay, the mathematical literacy and vocabulary. So we have 5 on the top, and we need to match them with the 5 pictures on the bottom. So, how do you want to do it? You want to start off with number 1 and find it?
Yeah.
Okay.
It's like nothing what we just
Yes, it is everything we just did. Okay, so this number 1, what's its HK?
1.
0. 0 what?
-5.
-5.
Why?
Because there's.
Why does it have the X
there's
in there?
an H.
Because we had x's, because it was plus or minus a, the square root of x minus h plus k, yes?
0, 5,
That's what was messing me up.
Okay,
0, 5.
so 0, -5.
0, 5 is 2.
Oh, for 2. We're going to do that first? That's fine. So 0, 5 for 2. What about 3?
5.
0, 0.
0, 0.
You're right.
What's special about 4?
It's negative.
So what's that do?
So negative 1, 0.
Nope.
0 for
It's
0.
0, 0.
That reflects.
And it reflects over the x. Okay.
And then
0,
0, 0 reflects over y.
Okay.
Is the 5 with the x, the a just multiplied?
Yes, it does the same. It affects the x value. So it does the opposite of what the other one would. But yes, it's the same as like an a.
Oh, we have to like match them?
Yes. Okay, just a second. Y-axis. So, well, we'll just go to A. We start at 0, 0.
And we go up.
So is it reflected?
3. No.
Nope. So which one's 0, 0 not reflected?
3.
3. Okay, B.
B.
0, 0 reflected over the what?
Y.
The Y, which
So
would be
5.
5.
That's on a,
C.
Oh, 5.
7 positive. Oh, we're doing C.
Well, we'll do A, B, C, or do you want to do E? I don't care. E? What do you want to do? I don't know.
do C.
C. Okay.
It's number 4.
It's still 0, 0, and it's reflected over the
X.
X, so it's
4.
4.
And
So where's my vertex here?
E is 2
5.
and D is 1.
So this is 0, negative 5. So that would be 1. And this is 0, 5, which you should write on there. And that's 1? No.
You.
No.
No.
2.
It's 2, guys. Come on.
Correct.
You need to lock in.
So on your back, we didn't talk about domain, but well, we did, but we didn't say
We do Damien's
domain.
function together.
Why? Okay, you guys do the 1. You do 1. Do 1. Exactly what we did here.
3, 0.
Okay, you guys do number 1.
Am I correct?
Ready.
You got number 1, Jenna?
0, 0.
No. A, B, C. Have you matched into 1, 2, 3?
Oh,
Already.
They're literally
I
in the
know,
order.
but I'm
right above each other.
Don't say that, and you're wrong.
okay, so 2, what's the free?
No. Yeah.
I'm gonna guess
Yeah,
one
no.
is B.
Shh. And they are not right above each other.
Huh.
A is B.
Okay, Jenna, by yourself.
Shut up. A is not. What?
Shh. Identify your H and K. We'll make that easier.
This is the only correct possible way.
So Regan, what's A?
1.
1.
You just said they weren't above each other.
They aren't. Lily,
All of them.
what's B?
3.
3? Yep.
Oh, I thought you were doing
I'm not.
City?
2 is C.
2 is C. Okay. Damien wrote a radical function that is represented by the graph. Describe the error he made, then write the correct function. So let's look at the graph first. What's its HK? 2, 0. And our parent function is y equals plus or minus a, the square root of x minus h plus k. Now, you should be able to, write that already, right? Because it's the same exact thing.
Yeah.
Okay, so what's wrong with his?
It's supposed to be seven.
It should be, his HK is negative 2, 0, isn't it?
Yeah.
Okay, so the correct equation is y equals what?
Square root of x minus 2.
Square root of x minus 2. Okay, it says fill in the blanks to find the transformation of the parent function for g of x equals the square root of 25 times x minus 5 plus 11. So it says factor out 25 among the terms in the Radican, which they did already. This would have looked like, and I don't know why they did it for you, this would have looked like 25x minus 125 plus 11. Okay, so when you have, and the reason why I did this is because I want you to see it. When you have a coefficient on that x, you need to factor it out so you can actually see the movement, see the h and the k. Because 125 is not your h. Your h is what?
5.
5. Everyone got that?
Yeah.
If you have a coefficient on x, you need to factor it out. It does still stay in the square root, but you need to factor it out. What do they mean by that? What does that mean?
Right?
It means that you have to find the Radican.
It's like the 0, 0 thing.
Oh. Okay, so product of radical. So is this multiplication right here?
Yeah.
Yeah.
So could I rewrite it as the square root of 25 times the square root of x minus 5 plus 11?
Yeah.
Okay. Now, after this, you'd never need to do that because what is the square root of 25? 5. So could you tell me that from up here that you could bring it out?
Yeah.
Yeah.
I guess.
So 5. So now is it an A now?
Yeah.
Yeah. The square root of x minus 5 plus 11.
And now the parent function is.
Oh. The parent function would just be this.
The x minus 5?
Yes. Oh, wait. Here it says graph the parent function f is stretched vertically by a factor of 5. Then the stretched graph is translated 5 units to the right and 11 units up. So this is, you will never write it like this. No, they wrote it wrong and I'm going to fix it. It's this. It's 5f of x minus 5 plus 11. Okay, because that f of is the square root.
So
That's
5
function
x
notation.
minus 5 plus 11.
That's square root notation. Does that make a function notation? Can't talk.
Capturing it in.
Just a second. If I want to have a worksheet. Would you guys like your worksheet to start on tonight?
Yes.
To start.
To start, not to finish. It is not due,
I'll wait till tomorrow.
but to start. Okay, how about I give it to you because in case you don't get here tomorrow. Okay?
Is this tomorrow's homework?